Okay, we're back. So we're leaving off, or we left off last time on question 5, which was up here, and we're picking up on question 6. Now before we start into 6, let's pick up with this again. Interpolation. So if there's a linear association between independent and dependent variables, so independent being your x, your dependent could be a y, sometimes represented as f of x. So those variables of a data set, you can use linear regression to make predictions within a data set. Key thing here, within the data set. So using a linear regression to make predictions within the data set is called interpolation. Again, within the data set. That's called interpolation. So now we're going to do some interpolation. Use your equation to predict the percent of total music sales that came from music stores in the year 2000. Alright, so to actually go about this, we're going to use some of what we derived already. And what we derived in the last page, let me pull that up real quick, is right there. So we used the calculator, and we followed all these, you guys followed all these steps here I wrote out for you, and we got our regression line values. So our rate right here, the negative 2.97, our y-intercept, where they started off in 1998, we got 48.89, and this here is using linear regression. So they want us to do it for the year 2000. So what we'll want to do here is we want to first write out the equation that we're using. We want to go y equals negative 2.97x plus 8.89. Okay, so we calculated this. Now the year 2000, if we look back at our chart, let me go ahead and flip to that real quick. Looking back at this chart from the previous page, in the year 2000, our input, our x value is 2, and our output is 42.4. We're going to calculate this here. So this is what the actual was. We want to compare that with what we're going to get in the equation. So we're going to use a 2. So right here, we'll take our 2, we'll put that in, and we'll go y equals negative 2.97 plus 48.89. And then put that in the calculator here. We'll go on, and we'll go negative 2.97 times 2 plus 48.89, and we get 42.95. So we get y equals 42.95. So we could say right here, what I do usually when I put an answer down, I take their question and I flip it into an answer. Use your equation to predict. So right here we want to predict the percent of total music sales. So we could say our prediction. So our prediction for percent of total music sales that came from music stores in the year 2000. So that's what I'm going to use. So I'm using predict to get the prediction, and then 4% of total music sales. Percent of total music sales that came from music stores in we're running out of space. 2000 is, and then we'll say 42.95%, period. And so that's how we do that one. And then for the next problem, it says compare the predicted percent in 2000 to the actual percent in 2000. So we could say the actual percent, so I'm using this part here, the actual percent in 2000, the actual percent in 2000 is, and if we look back at our page right here in 2000, the actual percent was 42.4%. And our predicted percent in 2000 and our in 1000 is I'm going to put a period there. So we could say, so our predicted value is fairly close to the actual value. Okay, let's look at the next one. Question 8, they want you to use your equation to predict the percent of total music sales that came from music stores in 2003. So again, right here, percent of total music sales that came from the music stores in 2003, I'm going to use that to write my answer. We'll use the word predict and percent of total music sales that came from the music store in 2003, just like we did up here. But first we've got to calculate it. So let's go ahead and let's write out the equation we derived with the calculator from problem number 4. Negative 2.97x plus 48.89. So that's our linear regression equation there. And in 2003, well, we got to look at how many years that is from 1998. We can take a look at the chart. 2003, that is 5 years from 1998. So we're going to enter 5 for the x. And we bring everything down. And let's go ahead and enter it in the calculator, because we do not have all the space. So let's see here. We're going to go negative 2.97 times, this time we're going to do a 5, plus 48.89, and we get 34.04%. So y equals 34.04. So now we could say about 34%, you know, if we were to round this, about 34% of total music sales came from music stores in 2003. I forgot to use the word predict this time. But basically our prediction is about 34% of total music sales came from music stores in 2003. Okay, and for the next question there, compare the predicted percent in 2003 to the actual percent in 2003. Okay, so the actual percent in 2003 was 33.2. So we could say, I'll just go in order this time. The predicted percent in 2003, we'll start off with that. The predicted percent in 2003 is 34.04%, and I'll put in parentheses about 34%. And the actual percent in 2003, so I'm just taking that and I'm going to write it right here. And the actual percent in 2003, and that's what they gave us. So we go back over here. In 2003, it was 33.2%. So we can conclude we can say the predicted value is close. I think these two are fairly close. 33.04% and 33.2%. Yeah. So the predicted value is close to the actual value. Okay. Let's take a look at the next part. Number 10, do you think a prediction made using interpolation will always be close to the actual value? They want us to explain our reasoning. Oh, well, let's take a look at this graph real quick. What if the data points were like scattered just all up and down, really odd, and they weren't really nice and aligned such as this? So using a linear regression, the line will go through the best fit, but the points are all over the place. It's not going to really match up nicely with each plotted point. It's going to just be the line of best fit. So in this case, it does line up nicely, but in other cases, it doesn't. So it really depends on the value set. So we'll say this. It depends on the data set. And the line of best fit. So in our case, all the points are nicely they're nice and close to the equation that we came up with to simulate the data points, our linear regression line. It's really close. So we could say if most of the points are near the line of best fit, then the predictions will probably be close. Similarly, if the points are not near the line of best fit, then the predictions they won't be as accurate. Okay. So we want to make sure we have all that. So you should have the first sentence, the second sentence, and the third sentence. It's got 3 sentences there. So to make predictions for x values that are outside the data set is called extrapolation. Okay, so let's make some kind of visual with that. Let's go ahead and revisit page 524 real quick. I want you to do something. Let me just go like this. This data set here, if we're focusing on this and using our line of regression within these points here, we'll call it interpolation. Now, anytime we go outside of it, I'm just going to kind of do this, meaning, you know, any other points. This here would be extrapolation. Similarly, on this side, previously to all this data here, we're also looking at extrapolation. So interpolation is within the data set. And what we did previously, those calculations, they were all within the data set. Now we're looking at going into the future where there's no data. So that's extrapolation. Or we're looking at going into the past. If this was populations and we wanted to know, well, what was the population in the past based on this displayed data? So we create an equation and then work it backwards, and we would predict, you know, maybe this was what happened. And it doesn't always work out to be a nice model. Sometimes it defies logic, as we'll see in some of the problems we're going to do coming up. So I'll go ahead and let's move forward. Alright, to make predictions for X values that are outside the data set is called extrapolation. Use the equation to predict the percent of total music sales that would come from music stores in 2010. Okay, so in 2010, we're going to go ahead and let's first set this up. Y equals, and then negative 2.97x plus 48.89. Now, 2010 and 1998, if you were to subtract them, you should get 12 years. I could do it right here. 2010, 1998. If we subtract them, we borrow from there, and when this cancels out, it becomes a 0. That's going to be a 2. We've got to borrow from here now. That's going to become a 9, and that's going to become a 10. So then we get a 1. 10 minus 9 is 1. 9 minus 9 is 0. So those cancel, and 1 minus 1 is 0. So we get 12. So, since there's a 12-year difference, that's what we put in for our x, 12. And then we bring our equation down. And let's go ahead and put that in the calculator. Whoa, what happened there? Okay. Negative 2.97 times 12 plus 48.89, and we get 13.25. So let's take what they wrote here for the question and flip it into the answer. Use the equation to predict the percent of total music sales that would come from music stores in 2010. So we could say our prediction for percent of total music sales that would come from music stores in 2010 is 13.25%. So we could say our prediction for percent of total music sales that would come from music stores in 2010 is 13.25%. 13.25%. And we'll put a little period after that. Okay, now they want us to do 2020. 2020. So for 2020, do the same thing. 2020, 1998. And we subtract them. What we should get is 22 years. So if we borrow from the 2, making that a 1, 10 minus 8 is 2. Borrow from here, that's going to become a 9. And 11 minus 9 is 2. 9 minus 9 is 0. 1 minus 1 is 0. So we've got 22 years. So here we go. Y equals, let's write out that equation we derived from number 4. Negative 2.97x plus 48.89. And I'm going to bring it all down. Notice how I stay nice and organized, and I write out each step so I don't get confused. And then we put this all in the calculator. Negative 2.97 times 22 and plus 48.89, and we get negative 16.45. So our prediction there gives us a negative %. That gets odd because there's not really a negative % that defies logic. But in either case, let's go ahead and let's write out, using the question, we flipped it into an answer, our prediction for the % of total music sales, our prediction for the % of total music sales that would come from music stores in 2020 is negative 16.45%. Negative 16.45%. Period. Now they want us to do some more extrapolation. They want us to go to the year 1900. So if we did the year 1900, we would go 1998, and we would need to subtract 1900. Actually, we would need to put 1900 on top and subtract it, because we're going backwards in time. And for this one here, we should end up with negative 98. You should see right off the bat, the 9s line up, the 1s line up. We end up with a negative 98. So, negative 98. Because you can see these 9s here, they're going to cancel each other. These 1s are going to cancel each other. If you borrow it, it'll still come out like this, so we're fine. Okay, so let's go ahead and write out our equation there. The equation we derived from number 4. Then we got negative 98. It's negative because we're going back in time from 1988, in case you're wondering that. And my alignment's a little off, but it's not too bad. You don't want to get too sloppy on it, though, or too misaligned. Okay, so let's plug it into the calculator. Negative 98 plus 448.89, and we get 339.95%. Again, a little illogical, because if you're talking about 100%, you can't go over 100%. You know, we're talking about percentages. So this here gets a little illogical. So we could say our prediction for the percent of total music sales that would come from music stores in 1900 is 339.95%. Okay, so now they ask us, are these predictions reasonable based on the problem situation? So we could say, if we glance at all these again, take a look at them. The one in 2010, that seems reasonable, 13.25%. In the year 2020, we have a negative for 16.45%. And in the year 1900, we have a 339.95%. So 2010 seems reasonable, but the predictions for 2020 and the year 1900, they don't seem kind of reasonable. Simply because it's impossible to have a negative percent and to have a percentage over 100%. So let's go ahead and write that out. And we can use this here. Are these predictions reasonable based on the problem situation? So we could say the 2010 prediction is reasonable based on the problem situation. So let's write that out first. The 2010 prediction is reasonable based on the problem situation. And then we'll use that over. The 2020 and 1900 predictions are not reasonable. Based on the problem situation, since we got to explain why. Since it's impossible to have a negative percent of sales. Or a percent over 100%, period. Oh, you guys can't see that, can you? My bad. Okay, so now we got all that there. Glad we discussed all that. All right, I think we're good.